Everyone, I'm gonna give it just a couple more minutes. I somehow set it to where I have to admit everyone manually, so I'll need to fix that. But maybe give it another minute or two and then get going. Okay. I think the trickle is slowed down, so I think we can get going. Can people hear me? Okay, cool. Okay, well, thanks everyone for joining us for this quick bioinformatics bootcamp. So I'm gonna have all these slides online so people can review them. And I'll just kind of start going through this. So there you go. So you can access all of the slides here. Let me just double check that this is recording before I get too far. Okay, cool. That's supposed to be an underscore right there. So I'll have all the slides up before the class starts. And then either the evening of or the next day, post the recording from the session on the YouTube channel that's listed in that little syllabus thing that I sent out. And so just to quickly overview kind of the purpose of this. So this is going to be broken down into 2-week chunks. So the first 2 weeks will be kind of the command line basics of using bioinformatics tools that already exist. That pretty much forms the backbone of bioinformatics, is processing, let's say, sequencing data, doing all the kind of the manual labor of that. And then the next 2 weeks we'll have a overview of Python and how to write some basic tools that can help in the post-processing steps. So one example of that is we'll take like a gene counts table from RNA-seq, and we'll have an identifier name for each gene, and then we'll convert all of those into their common names. So things like that. And then the last 2 weeks will focus on kind of the statistical analysis and visualizing data. And so hopefully this doesn't seem too much of an info dump. I think the idea is to conceptually introduce everyone to these 3 kind of the basic pillars of bioinformatics. And then the idea is knowing what you'll know at the end of these 6 weeks to be able to determine, okay, maybe for my research, it's more useful for me to learn more command line, or maybe I'm more interested in the visualization aspect. So I'm gonna focus on learning more R. And we'll talk about some resources where you can continue kind of building that background in whatever language you decide to pursue or whatever niche of bioinformatics you work on. I think I kind of talked about these points already with that last slide. And feel free, if you have any questions as we go along, chime in or ask a question on the chat. I have that open on my side so I can see any question that's asked there. So with the class structure for each of these 6 weeks, We're going to meet Monday and Wednesday at this time, and this will be more of the conceptual lecture-based class. So if something doesn't make sense right away, that's fine. At the end of each of these lessons, there will be a homework assignment to work on. We're able to review some concepts from the lesson that day, and kind of get your hands dirty with the actual coding aspects of things. And then on Fridays, that will be just that's, I guess, could be considered more of an optional class where if you're wanting more practice and hands-on help working through something and troubleshooting something, then that's what the purpose of that Friday class is. So, and we'll have one at 10 a.m. and another at 5 p.m. each Friday. So I'm gonna lead that Friday morning session, and then Ian, who works with me, he'll be leading that Friday evening session, and I'll be there during the Friday evening session as well. And so you can kind of get both of our inputs and methods for how we would approach a problem there. Okay, and just some, I guess, quick, hopefully to reassure you. So just like with any language, learning any new language, programming is just like that. It's going to be difficult. It's going to take time and practice. But with more practice, just check that that's not my Slack. Okay. So just like with any language, with more practice, that fluency will improve. Don't be discouraged if you need to Google every single thing. So I have been coding for, I think I took my first course in 2014. And there's still stuff that I've done 50 times that I still need to Google to remind myself, oh, how exactly do I formulate that command? So don't be discouraged if you need to do that. A big part of programming is basically reading the manuals, reading different website forums, and figuring out how do I approach this. And as well, I think so I would say your first line in troubleshooting should be Googling the question. And then that second line of, I guess, defense should be on the Slack channel, asking your classmates, hey, I'm having troubles with approaching this problem. Do you have any advice how you would do it? And I encourage you not to, I guess, solve the problem for the other members of the class, but kind of help them just take that next step so they can work through that mental process of figuring out how they would approach that. So sorry if I'm adding you a little bit late. I'm accidentally made it so I have to manually add everyone to the session. So I'm going to fix that next time so you can just automatically be added. And just one final word of advice is if something's not working, break it some more and keep on breaking it until it works. I just finished troubleshooting something today that I've probably spent, just for the one task, it took me collectively 10 to 15 hours to troubleshoot. I think with these problems that we're going to be talking about, it definitely won't take that long. But for this and with a lot of stuff that I've done, it takes maybe 5 to 10 iterations to get to something to work. And that's totally fine. That's part of the process. Okay, so before we continue, does anyone have any questions about the format of the class or just any other general questions?
Just to reiterate, Jordan, you said that these sessions will all be recorded and available online if we want to review them later?
Yeah, they will. So either tonight or tomorrow, I'll repost that YouTube channel, but these will all be recorded and on YouTube for you to review and go back over. And then again, all of these slides will be here on this URL. And I'll post both of these back in the Slack channel just so they're easy to access.
Cool, thanks.
Yep. Okay, so first concept before we actually talk about the coding itself is pseudocode. So this is a really helpful way to approach a problem and make sure you have a challenge, you organize each component of that challenge down to the component parts. And so you know exactly how you're going to build that script to analyze some data or whatever it might be. I think you can draw easy comparisons in wet lab experimentation. If you're going to extract RNA, you don't just extract RNA. There's a process to it. There's a certain order of operations that you need to follow in that protocol. And so just like that in programming, it's the same concept. And so, and just like that, your code would be analogous to actually using the pipette, processing the samples, where pseudocode would be planning out that protocol beforehand and saying, okay, in order to achieve this final goal, these are the 10 steps I need to work through to get there. And so an example of this might look something like this. So I would kind of outline the purposes of the script or the function that I'm going to build. So this one is just having the user input a number, determine if that's a whole number and whether or not that's even or odd, and then tell the user this is an odd number, this is an even number. And so in order to process this, I would take the user input, I would check that the input is a whole number. And in programming, we're going to refer to these as integers. We'll talk more about the data types in a, can't remember if it's today or tomorrow, but there might be a later lesson. And then evaluate, is this even, is this odd, and print that out. And if it's neither, tell the user. If it's a number with a decimal point, something like that. So, and then I would basically take each of these kind of notes for myself, keep them in the actual code. And then I'd say, is this an integer? If it is it even? If it is, print that. If it's not, print odd. And if it's neither of those, tell the user. And don't worry too much about the syntax here. We're going to talk about more of that. But just to give you a quick example of how pseudocode might convert into actual code. Okay. So what we're going to start with is hopefully everyone's filled out that supercomputing resource application and has had that confirmed. If not, let me know in Slack after class, and then we can make sure you're able to access those resources. And a lot of the stuff that we're going to do, you can do on your personal computer, but a big reason for getting everyone on the supercomputer is to just make sure everyone's on the same computing environment. That'll help work through things. And also, like when you're processing sequencing data, it may take 24 hours to process one sample on your personal computer. But by putting this on the supercomputer, it lets you submit the job, step away, come back when it's done. And also their computing resources are a lot beefier, so you can process stuff a lot faster too. So in Mac, or if you're working with Linux, I think everyone was either working with Mac or Windows. So an example of how you would log into the supercomputer is you can just go to the Finder. Let's see. So you can go to the Finder, type in terminal, hit enter, and that should open up a window that looks something like this for you. And what you're going to do, so every time you see one of these $signs, anything after that, that is the start of a new command in terminal. And so we can say, so the way that you log into the supercomputer, you need to use the SSH command. This is going to log you into the secure supercomputing resources. And then you would give it your UID at notchpeak.chpc.utah.edu. So this is just my UID and then this is the specific supercomputing cluster that I'm going to be logging into. So then all I do is hit enter here. It's going to ask me for my password. I will enter my password. And you'll notice even though I typed in my password, you don't see any text being entered. This is so that, say, one of your coworkers is next to you, they don't even know how many characters are in your password. And so it's just a security feature. So even if nothing's showing up, it's still registering your keystrokes.
Hey, Jordan.
Yeah.
Sorry. Do we need to be connected to the VPN client to do that?
You do not need to be connected to the VPN. So there are some times that you would need to do that. This, for just general supercomputer usage, you don't need to worry about the VPN.
Okay, thanks.
VPN is for when you're processing protected like patient data. So if you ever do work with patient data, that's when you'll need to worry about that. And you'll need to be logging into a different URL as well.
Thanks.
Yep. Okay, so I am logged into the supercomputer, and you should see something like this print out every time you log in. At the end of my session, when I'm done, I would just type log out, and it'll take me out. So let me just go back in. So then if you are working on Windows, you'll need to use something called PuTTY. This is an open source like supercomputer resource accessor. So you're basically using this SSH command within this app. And so when you open this up in Windows, you would, for the host name, enter notchpeak.chpc.utah.edu. I think when you open this, it should ask you to verify the host key. And if it's your first time logging into the supercomputer, they'll say, are you sure you want to trust this? You can say yes. And then it should ask you for your username and password, so your UID and just whatever password you use to log into CIS. You use that. And then you should see a window open similar to this where it's telling you you're in the supercomputing node. And then at that point, whether you're working on Mac, Linux, or Windows, everything from here on should be the same. And if it's not for some reason, let's talk and troubleshoot through that. So let's talk a little bit about computational biology and just kind of the history. We're not going to talk too much about this, but just to kind of give some context. So computational biology, even though it's kind of more in the spotlight nowadays, this was originally born in the 1960s, early 1970s, and a lot of that was with protein sequencing. And so if you're trying to align two sequences by hand, this would take potentially days, but by letting the computer do this literally, especially nowadays, saves you literal lifetimes of doing this by hand, if it's even possible to process something by hand. And so we're going to be talking a lot about Unix or Linux. So this is what this all is. So this is the command interpreter and basically the underbelly of your computer. It's a lot of like you're using Slack or Zoom. A lot of this is using Unix as the underbelly. And this is where a lot of the basic computational genomics is going to be done. And so it's very important to learn how to use Unix-based systems in order to be able to analyze your own data. And so we'll also talk a lot about, so this command interpreter, this is also known as the shell. And so this $sign there, that is the, I guess, shell prompt. And so anything after this $sign is going to be interpreted as a shell command. And this is basically your portal to using all these bioinformatics tools. So let's talk about the basics of Unix. And so hopefully everyone was able to complete that, the kind of intro to Linux that I sent out. So we're just going to review some of those pretty quickly. Hopefully everyone's familiar with these, but I guess we already talked about this. I think it's very important to remember that computers are dumb. They only do what you tell them to do. And so if you misspell something or you don't capitalize something where it's supposed to be capitalized, it's not going to know what to do. And so you're going to have to, it may say, oh, I don't know where that command is, can't find that. It may just be that you misspelled it and then it'll work fine. And so the way that you navigate through the file structure in a Unix file system is very similar to any file navigation system. So it's going to work in this tree tiered structure. So maybe these aren't organized in a linear fashion, but just a quick helpful hint. So there's a lot of shortcuts that you can use when you're trying to go back to a command or something. And I'll kind of demonstrate this as we go through. So if you want to go back to an old command, you might press the up arrow and that will cycle through old commands that you can run or modify. With this, you can't just click in the middle. You need to use the arrow to navigate in that word to modify the command. And you can say, I want to go to a file, you can just hit the tab if you start typing out that file name. And if anything ever goes wrong, it just starts spitting out a bunch of junk that you don't know what's going on. Hit Control-C, and that should kill the command. We already talked about this. Sorry, this is kind of out of order from the file structure slide that I had before. Okay, back to the file structure. So we're here. But anytime I want to know, so specifying the absolute location of where a file is or where a folder is very important, or else Unix won't be able to find what you're looking for. And so if you're ever at a location and you need to know exactly where you're at, you can use the pwd command, which is print working directory. That's going to print out the absolute pathway to your current working directory. So if I just type pwd, enter, that will tell me exactly where I am in the supercomputer. Okay, now how do I move somewhere within this structure? So this command is cd, so this stands for change directory. So within my home directory, in the supercomputer, which the shortcut command for that is just this tilde sign. So if I want to go to a file named test, I would do cd test, enter, and now I'm in the test folder. So I'm going to go back and just kind of demonstrate that autocomplete. So if I want to, let's say I'm going to go back, we'll talk about this a little more. But so I want to go back to the last command that I run. I'm just going to hit the up arrow. I can run that command again. say I just want to be a little bit lazy and autocomplete this folder, I can do cd tab. It'll give me some options. Test is the first option, so I can just go with that, enter, and I'm back in test. Okay, so I'm gonna stay in the slides a little more. Won't switch back as much back and forth, but I'll have basically anything I would do is shown in these little boxes to the side. And just keep as a reminder, anywhere where you see this $sign, that's where I'm entering a command, and then anything below that until the next $sign is the output for running that command. Okay, so now another command, if I want to find out what other files are around me, you can use the command ls. So this just stands for list. Maybe we'll just switch back a little bit more. So if I want to just show what is in the current directory, I would just use a period. If I want to show what's back one directory, I would use 2 periods. And this is any command that you're using in Unix, you can use these same shortcuts here. And then anytime when you're specifying a pathway of multiple folders, you need to specify those folders with this slash. So let's demonstrate this real quick. I want to see what's in this folder here. I can do ls period. And this shows me here all of the folders are highlighted in blue and all the files are in white. If I want to show what was in the folder back above me, so that was in my home directory, I do ls space ... and then you see all those files. And say I want to, so within test, I have this home directory. I want to look 2 directories in. I would do ls test home. Oh, okay, sorry. I'm not in my home directory right now. Okay, ls test home. That brings me basically 2 layers in there. Okay, and so I don't think I said that, but so because I had 2 folders that I was working my way into, I need to separate each of those by that slash. And again, I need a space after the command, which is ls. I can't have any spaces in these file names because there are no spaces in these file names. It's very sensitive to those kind of aspects of typing this in. And okay. So now I want to make a directory within my current folder. I can use the command mkdir, so that's make directory. So say I want to, let's see, in here, let's go into the home directory, cd space home. We'll make one going with the Star Wars theme, Vader. So make directory Vader. I type ls again. And so now you saw the first time I ran the ls command, I just had these 3 directories. Now after I run that make directory command and type ls again, we now see that new directory displayed. If I want to make a new file, I would use this command called touch. I don't really know the origin of this term, but it's touch. So here, if I want to make a file within the Vader folder, I can do touch Vader, and then we'll do anakin.txt. So I'll make a new folder here. If I look at what's in the ls folder, I now see that folder file there. If I wanted to make this file in my current directory, I could just do touch.anakin. Or if I wanted to put this in the directory above me, so I think that was the test directory, I could just do /anakin.txt. Okay, I'm going to take a quick pause here and just see if anyone has any questions so far. If I'm going a little too fast, let me know.
Hey, Jordan, this is Kristen Davenport. I have a quick question.
Yeah.
Are these all Linux commands? So if we're in the supercomputer, that's fine. But if we end up trying to deal with Windows, we should not, or we should do a Linux system or something.
Yeah. So with Linux commands, almost every single command that we'll try using, you'll be able to use in Mac in that operating system. In Windows, a lot of commands will transfer, but not all of them. And so you may have to just do a Google search and say, hey, what's the analogous command for this in Windows? But again, so in the supercomputer, you do have an interactive node that you can use, so you don't have to submit a job. If you just want to test something real quick, you can run that interactively within your directory. And yeah, that should work in most cases.
Okay, thanks.
So another question in the chat, I tried making a directory on the supercomputer. It says permission denied. So not totally sure what's going on there. You might want to run that pwd command and just see if you're in a directory, if it prints out something with your UID. If it doesn't show something with your UID, it means you're not within your own directory. You're in the kind of administrative space that you can't modify. And so that may be why you're getting a permission denied. Okay, it does have your ID. Let's maybe come back to that at the end, and maybe we can troubleshoot that step by step if we have a couple minutes at the end. Okay. Okay, so now say we want to add text to, weird, okay, oh, there it is. So I want to add text to this file that I just made. So the first option is after you specify the text that you want to add somewhere, you add this caret, and then you provide the file name. If you already have a file that has text in it, and you want to append text to the end of that file, you would use a double caret here, which I'll demonstrate in a second. And if we want to just read a file to see what's in the file, we would just use cat. So this stands for concatenate. This function has a lot of different purposes, but one of those is to display what's in a file. And then you'll see here in this example, I'm using this command echo. So in Unix, this is the print function. So it's just saying whatever you see in quotes after this command, basically repeat that or print that to the output here. So here I had, so again, I'm in this file structure. I made this Anakin file here. So if this file was in my current directory, I could just say echo, I am your father. And it's important that whenever you write text like this, you need to, if you open a quotation point, you need to close that, or else it won't know where that text or that, what's called a string, ends. So then, since I've never added text to this file, I can just use one caret. even if I've never added text, I could also just do a double caret. It's going to demonstrate the single caret option here. So if that Anakin file is where I'm at right now, I could say either anakin.txt. I could, if I want to be a little more specific, I could say /, so say this is my current directory / this file. But since it's in that Vader file, I need to specify Vader / Anakin.txt. So I'm going to run that. And then I want to add another line to this file. This time I'm going to say echo no append Vader / Anakin.txt. Okay, so now I want to read what I just threw in this file, so I can do cat Vader Anakin, run that, and I will have each of those lines output as I input them into the file. But let's say I have this file that has a couple lines on it, and I go back to this command, and we'll just say, I hate sand. So I'm using that single caret, no double caret, which would append. If I were to run this and read that file again, those two first lines disappeared. I only have that new line. And so by default, it's probably best to just use the double caret command, because you could risk overwriting a file, because it's not going to check with you, hey, you already have something here. Are you sure you want to overwrite with this? Once it overwrites that file, you can't take that back. So I would recommend just using the double caret option there. Okay, so now let's say I have a really big file, and I only want to read off the first 10 lines so it doesn't just consume that console. So you can use either the head command or the tail command. So the head will, by default, print out the first 10 lines. Tail will, by default, print out the last 10 lines of the file that you specify. And then you can modify this by adding what's called an argument. So you would say head-n15, and this would now print out 15 lines instead of 10 lines. So I think I had this file somewhere. It looks like it disappeared. That's okay. I have an example shown here. So I ran head test.txt. So this is a sequencing file. And so this printed out the first, I think this is actually not lined up right, but the first 10 lines there. Whereas when I ran tail-n4 with that file name, I only get the first, the last 4 lines of that file. Again, if you try to print out the full, if you do like cat space test.text or FASTQ, maybe it's 30 million lines, it's from a sequencing run, you're just gonna kill your computer, and you should just type Control-C to kill that command and save yourself some heartache. Okay, and so maybe you have a file with really long lines or multiple lines that you want to be able to scan through, but you don't want to just overwhelm the console. You could use this. So instead of cat, you use less space dash capital S. And then you'll be able to use your arrow keys to kind of move up and down, left and right. So we're going to talk about this file type later, but if I were to run cat copy.gtf, so this is a transcriptome reference file, which is, I think, 100,000 lines. if I want to be able to scroll through this, instead I would do less dash capital S copy.gtf. Run this, and now I can use my arrow keys to scan right and left, or down and up. You should be able to also, if you want to go whole pages at a time, just do D. This will go a whole page, or U, that'll go a whole page up. And when you're using less, if you want to exit out, just type Q, and that will bring you back to your console where you can type in another command. So that's a good question. So question, could you repeat what the dash capital S argument does? I don't know for sure. I think basic less just lets you scan up and down. Less dash S, I think, lets you scan left and right. So I can share, I think I was going to talk about this a little bit later, but say you don't know what a command is doing, or you want to find out what all of the arguments are that are available. So for a lot of basic Unix commands, you can type man space less. So man is just short for manual. So if I were to run this, this throws out this synopsis of what this is going to be doing. And so I can use my arrow keys to scan through, find where that capital S is. Maybe this is alphabetical, I'm not sure. Okay, I can't find it, but you can look through the manual. That would be a good documentation training exercise. Look through the manual for less and figure out what that dash capital S is going to do. And with a lot of these, a lot of times the capitalization will matter. And so something that capital S might do, a lowercase s might do something different. So be aware of that. And so with any of these manuals, type Q and you'll quit out of the manual. So now if I want to see how big a file is, so I can use this WC command to print out a lot of kind of quality control metrics about a given file. So I would run WC copy.gtf. And then this is going to give me 3 different numbers followed by the file name. So if I were to go into man space WC and look at what this is doing. So this is going to print the number of new lines, or just number of lines, the number of words, and the number of bytes. And so this is going to be the number of characters essentially. So if I go back and look at this, there's 41,000 lines, almost 1 million words, and interesting, that's showing not much different. So maybe the bytes isn't showing exactly characters here. I think if we were to look at the that just plain text file that we made, that should give us around the number of characters that we actually used. So I think that won't exactly give you a character count in every situation. No, okay, sorry. So this is 100 or 1 million words, 10 million characters. So that sounds about right. So, and also if we want to just kind of look, so maybe I'm only interested in the number of lines, so I can use this -L command. So if I were just do WC -L space file name, so going back to that text file that we made, it's only going to give me 1. There's only 1 line in that file. Okay. So now it's time to talk about a dangerous command, but it's also pretty important, especially with in your home directory on the supercomputer, you're limited to 50 gigabytes of space. So if you have an old file that you don't need anymore, you want to remove it. So I'm going to show you how to do that. You got to be very careful because once you delete this file, it's not going to check with you, are you sure you want to delete this? It's just going to delete it. You won't be able to recover it. So here, I would say rm space Vader / Anakin, enter. And if I were to look inside the Vader folder, that file is gone. If I want to remove the Vader file, just by using rm, it's going to tell me I can't do that because it is a folder or a directory. So I need to give it this -r option, and then it will remove the folder. So if I go back and look here, that folder is gone. Whenever you're using this function, double check what you typed in. If you have two files that are just one character off and you put the wrong one in, and you meant to delete one file, not the other, it's going to be too bad. You're going to lose that file. I think that is a very important lesson. Whenever you're working with files, make sure you have a backup of your raw data files, because if you delete the only copy of a sequencing file, it's going to be gone forever and you won't be able to recover that. So be warned. Okay.
Hey, Jordan.
Yeah.
I had a question for you. Do you always have to type the file extension when you type in the file name?
Yes. So
also, I don't know if this is a related question, but when you add text or append text, can you do that only to a .txt file, or you can do that to any kind of text file?
you can do that to any plain text file that renders in your console. So like that GTF file, I was able to read it just off the bat. So I could just add a new line to the end and that would be there. Some files, like if you were to try to, so this BAM file, this is written in binary. So you wouldn't be able to add a plain string or phrase to the end of a file if it's binary. I mean, technically you could, but it would corrupt that binary file. And yeah.
Okay.
Did that answer? I think there's two questions. Did that answer both of them?
Yeah, and also, so we need to mention the file extension or type in the file extension along with the name.
Yeah, so you do need to include that file extension. So there is one exception to that rule. So say, I'm just going to make that Vader directory again, go on there. So say I made test1.txt and test2.txt. So maybe I wanted to remove all files that end in .txt or all files that start in test. So I could do remove test asterisk, and that will remove all files that start with test, and then it'll autofill the rest of the way down. I could do this with, say, asterisk.txt. That will target all files that end in .txt. Or maybe I want to be super specific and say test. Anything that starts with test and ends with .txt, remove that. So now I need to add an even more like severe disclaimer here. If I were to say remove asterisk space .txt, this is not going to just target all files ending in .txt. If I had a bunch of other files ending in different extensions, it's only going to evaluate rm.star and then stop evaluating after the space. And so any file you had, regardless of pattern you gave it, is going to be deleted. So be super careful using the asterisk, especially when you're deleting files. But that is a way, if you have like 1,000 log files that you want to delete, that's a good way to do it. But just, again, be super careful. You can get yourself in a lot of trouble, and you don't want to delete lab mates data either. Okay. Another question, in general, what's the difference between less and more commands? So another option that we could use, more copy.gtf. So I actually am not sure. So I always use less. I think it's because it lets me kind of scroll up and down. But if we just use man more. So this, it sounds like it only lets you scroll page by page. You can't use your arrows to scroll line by line. So I think in general, using less dash capital S is the most flexible option if you want to scroll through a file. And I think that's why I don't really know what it does off the bat because I never use it. I think less should be your go-to command there. Okay, and then so we talked about this already, logging out of the supercomputer. When you're done at the end of the day, just type log out and you're out of your session. So I have this slide at the end, just kind of summarizing the commands that we talked about today, just for quick reference. And so here is a kind of a hands-on task to do before next class to get some hands-on practice. And I would encourage you to try other things. Don't just limit to yourself to these 9 tasks. Mess around with things. Try to do something wrong and get an error and figure out why you're getting an error. Just don't accidentally delete all your files. Be careful. Don't mess around with that aspect of things. So that's all I have. I do want to mention, I forgot to make a slide for this. I'm just going to use a quick shortcut to get back on the supercomputer. So this is combining a couple different commands that we've looked at so far. So I'm going to go back to that test directory, home. So this is where that GTF file was. So if you remember, if I do less-s copy GTF, this is going to give me the entire file. But maybe with a file, I don't want to be working with the whole file. I want to create a test file. So what I can do is I can read that whole file with cat. So copy.gtf. And then I can use that caret symbol to basically send, actually, sorry, not cat. So let's say we want to take the first 100 lines, use the caret, and then we can just say small copy.gtf. And so when you're piping this output to a new file, this file doesn't already have to exist. You can give it a new file name and it will create that file on the fly. So I'm going to run this. And now if I were to just run the word count -l on the small copy, I now have 100 lines instead of the, I think, 40,000 lines or whatever. And then if I actually look at that file, small copy. So now if I just kind of scroll down, it's going to stop me 100 lines in because that's all that exists in this file. So I like to do this when I'm testing a function, like say on a 10 gigabyte sequencing file. And if I just want to test something real quick and see if it's going to work or not, I don't want to wait 10 minutes to figure out that. And so I might just make a file with the first 100 reads and test on that. So another question, is there a way to copy text from the middle of a file? I do not know. I can look that up real quick. I would assume that with header tail, you could probably specify a range of lines. But head for middle of file. So here, So I would recommend if you're Googling things, if you see something from a Stack Exchange or Stack Overflow, that's a good forum to get help with something. Yeah, so it looks like there is a way. It's a little more complicated using some features that we're going to talk about in a future lesson. So maybe we can revisit that a couple classes in once we've talked about some of those other principles. So this is my last slide. We have some more time if people want to, if they have any more questions or if they ran into an error as they were following along, if they want to copy and paste that, their commands and the error into the chat box, we can troubleshoot those for a couple minutes. I think I'll stick around for another 5 to 10 minutes so we can use that time to do that.
Hey, Jordan, can you hear me?
Yeah.
I had a question. Is there some way to look at the tree of folders and files that we'll be working with in the supercomputer the same way if I opened up, a documents folder in my Windows interface?
Yeah, definitely. So I don't know. So you might want to try this and tell me if I'm right or not. I think this command comes pre-installed in the supercomputer. If not, you may need to install it. But so what I can do, I'm in the home directory. I can just say tree space period. So this is going to give me the tree from my current directory and everything below that. So when I run that, it's going to say, okay, here's the current directory. And this first here, here's the files and folders. Within that, here's the files and folders, and so on and so forth. And so this is going to go all the way down in each folder until it hits the end of that folder. Does that work for you on the supercomputer right off the bat, or is it?
Yeah, I made a fake folder just called new folder, and it did show up when I put that line in.
Okay, cool. Yeah, so if you kind of want to look at where you want to go next, this is a useful feature. Okay, so now we have an error. This, let's type this. Interesting. Okay, so someone tried logging in and it gave them the question of authenticity can't be established. Are you sure you want to connect to the supercomputer? I think they tried a couple times and then it errored out. So it added the host and then it broke the connection. Did you try logging in again after it kicked you out, or? Okay, so maybe try logging in again. So that's that SSH space, your UID at hp.chpc.utah.edu. Enter your password and see if it kind of flows through there this time.
For some weird reason, it's not letting me type in the password.
Okay, so with a password, so here, can you see my screen still?
Yeah.
So when I enter my password, you're not going to see any text showing up. So I just entered all the characters. You don't see anything. But when you hit enter, it still recognizes all those keystrokes.
Okay, so I actually typed something, and can I like undo it? Like, how do I know how much it has typed?
You don't, and so you can either just do Control-C to quit out and try logging in again, or I'll just like hold the backspace button until it's like gone 50 spaces back. I know it can't go back any further. So like here, I'm just going to use my shortcut again. Ask for my password. I type a bunch of gibberish. Oh wait, I think I made a mistake. I'm just going to hold the backspace button.
Sure.
Well, I'm sure
I,
it's
I
done.
I did it actually, so it's kind of connected me this time. So it looks like it's working.
Okay, cool.
Awesome, thank you.
Yep. Okay. So if no one has any other questions, and feel free to jump in and interrupt me if you do. So go ahead and practice this stuff and do this assignment. If you're into issues, Google search, ask on the Slack channel. I am going to not answer at first on the Slack channel and kind of give other people a chance to help each other troubleshoot. I think that's one of the best ways to learn is helping each other troubleshoot. And if people get really stuck and need some help, just ping me and I'll jump in and see if I can help you. And then after we're done, I'm going to load this onto YouTube, and then I will post these links back in the Slack channel just so you have those quickly available. So if anyone has any other questions, let me know. If not, I will sign out for the day.
Thank you.
Thank you. Okay, I will see you all on Wednesday evening.
Jordan,
Yeah.
quick question. So when you make your directory on the computer, how do you know it's actually there? So I just put make directory whatever, but when I put it under, and then I put pwd, but it doesn't show me under that particular directory.
Did you do the cd command where you, so I can, it's like if I were to make a test2 directory,
It says the directory doesn't exist. That's the problem.
can you type ls and see if kind of where you're at and see what other files are around you?
Okay, I could try that. Yeah.
Okay. Yeah, if it's still being problematic, you can copy and paste what you've tried in the chat right now, or copy and paste it into the Slack channel.
Okay, great. I'll do that. Yeah.
Look for it.
I'll do it on Slack. Thank you.
Yep.
Thanks.
Okay, and a question about what time will the lesson be available? So the recording, it kind of just depends on how long it takes me to get the recording uploaded to YouTube. I'll probably start it soon after I sign off. And I think by the morning it should be up, but I'll let everyone know when it's up for sure. It should be up by tomorrow morning though.